The broadcast is now starting. All attendees are in listen-only mode.
Good day, everyone, and welcome to today's SecurityBoulevard.com webinar. We're excited to have you with us. Our topic today is software-defined segmentation done easily, quickly, and right. We have an amazing speaker lined up for you, and today's webinar is sponsored by Guardicore. My name is Mitch Ashley. I'm your host and moderator for the webinar. A few housekeeping items. First, we are recording the webinar, and we will send out an email to all participants with a link to the recording and to the slides. You can also download those on securityboulevard.com. Also, our speaker today loves questions, and he has a lot of content to share, and we're happy to entertain questions while he's speaking. So enter your questions as the topics are flowing along, and we'll try to interject as many questions as we can. So let's move on to our topic, software-defined segmentation, done easily, quickly, and right. It's my great pleasure to introduce to you Dave Klein. Dave is Senior Director of Engineering and Architecture at Guardicore. Dave, baton's handed over to you. Take it away.
Thanks so much, Mitch. Really appreciate it. Good to be here. As Mitch said, I'm Dave Klein, Senior Director of Engineering and Architecture for Guardicore. So the goals of today's webinar are to talk about software-defined segmentation. I want to talk about the challenges driving the adoption of software-defined segmentation. I want to get into why software-defined segmentation, what are the use cases, get into the steps in rolling it out, and then also take a section to talk about the pitfalls. We've seen traditional segmentation, firewalls, and even some first generation of software-defined segmentation solutions fail. So we'll talk about some of the scenarios that you have to avoid. Finally, we'll get into probably an in-depth session on what the requirements are for software-defined segmentation. And by the end, you should know how to do software-defined segmentation easily, quickly, and right. All right, so what are the challenges that have led to software-defined segmentation? So in this era, more than any other era, we've seen business value IT as a way to be a competitive differentiator, to bring accelerated delivery into the workplace. They also see IT as a way to do cost savings and resource conservation by taking advantage of the efficiencies that IT has developed. And also we see business demanding better integrations and access. By this I mean often the enterprise is open to consumers, customers, contractors, suppliers, and business partners. And access meaning you have tons of contractors who are also in those enterprises. And we've seen IT respond by adopting a DevOps cloud model. And what's important about this DevOps cloud model is if you're an enterprise that hasn't moved to the cloud, it still involves you. Even in traditional environments, these use cases apply. It's a method of how you speed up and accelerate development and IT goals and movement through automation, auto-scaling, and using playbooks, scripting like Chef, Pup, and Ansible. So the point is, this is across the board, even if you haven't adopted cloud. So in doing this, in speeding up delivery and opening up your enterprises to your contractors, your vendors, and everyone else, all these integrations, there's a lot of benefits, but there's also risk and compliance concerns. And these are huge impediments for adopting this new model. And as far as IT is concerned, the next thing too is, how am I going to do this with a heterogeneous environment that I have today? So we see enterprises have a very heterogeneous environment, and how am I going to get visibility and manage it in a uniform fashion? And that is where software-defined segmentation comes into play. It's a way to take advantage of this acceleration and access, but mitigate risks, validate compliance, and give IT an ability in a unified fashion to look at their heterogeneous environment from a single pane of glass. I'm sorry to use that IT bingo buzzword, but from a unified visibility perspective and from a granular control perspective. So point on the name. The name is software-defined segmentation. It's also been known in the past as micro-segmentation. This is a word that we originally, when my company started, we used a lot. And I found out in going in front of customers, it's often misconstrued or misinterpreted. A lot of people think of micro-segmentation as a very small single use case in segmenting between the tiers of an application. So that's why we kind of switched to software-defined segmentation, because there are literally hundreds of use cases, even in traditional environments, where software-defined segmentation can help. So for example, these use cases, We have digital crown jewels protection. We see people using software-defined segmentation to easily secure point-of-sale systems, medical devices. We have customers who have development, user acceptance, and production environments and need to separate those. We have things like Internet of Things, like building controls, users, data centers, cameras. We have protection of legacy applications and operating systems. When I go out and see my enterprises, often I'm told we have Windows 2008 and Windows 2003. I know I should be off those platforms, but I still have them. So they're using software-defined segmentation as a way to protect these legacy apps, as well as micro-segmentation between the tiers of the application. Besides digital crown jewels protection, often software-defined segmentation is led by compliance. So any number of different compliance standards, and there's quite a number you see on the page here, we work to help isolate the environments that need to be compliant, because this is a way to reduce your workload, and are able to help validate and ongoing validation of those environments. And finally, there's a bunch of other ones that go under the data center transformation icon. Stuff like mergers, acquisitions. Often you're inheriting new infrastructures and new parts of an enterprise that you haven't worked with before. Cloud migration and hybrid cloud integration. So steps in rolling out software-defined segmentation, there's 5 steps. The first step at 12 o'clock is to discover, visualize, and map your environment. You need to understand your applications and what you have and what the application workflows are, the application dependencies. And then you go to label and group. So once you know and map out what your enterprise looks like and what the application workflows are, you're able to apply labels and groups. And often these labels and groups will be different for different crews. So for example, let's say you have a PCI concern. That group will want to label in a certain way, PCI and non-PCI, where a different group might want to choose a different labeling schema. So you have to be flexible for that. You define your policies, then you monitor and refine the policies as you go. And then finally, you switch to enforcement mode. And this is a big circle. Usually what you do is you start with low-hanging fruit, go after what matters most, and you go through this routine of these 5 steps for each part of your enterprise. So learning from traditional segmentation fails. So just as we've been successful, part of that was learning from the mistake of others. And there's a real problem with traditional segmentation. Of course, what people try first is traditional segmentation. And the problems are, across your heterogeneous environment, they can't be applied equally, evenly in a single way. So for example, on premises, people use VLANs and ACLs. In clouds, they use security groups. And the challenge here is you have to combine these multiple techniques together. So they're platform specific. VLANs are only for on-premise, security groups are only for clouds. And the challenge also is in the cloud environment, people think this is the new brave new world, but the thing is, it's kind of unusual. Each of the cloud providers has their own way of implementing security groups, and they're per VPC per cloud. So if you think about it, if you're an enterprise that has more than one cloud, more than one VPC, it just adds to confusion. Also, it tends to be management and resource intensive. Because you have to use multiple techniques to make this happen, it's very difficult to manage the number of resources required and the cost. Also, there's a lot of delays. When I talk to people this year and say, hey, how long does it take to change VLANs or change IP addresses? They say it takes months. It's an act of Congress. It's a real problem. So you end up with a lot of delayed and stalled and even failed projects. And also these traditional techniques don't have any visibility included in what they do. And so you can't map out easily traffic flows and app dependencies. You can't find ways that the applications are behaving appropriately, how they behave, and it leads to a lot of delays, even false positive blocks in some situations, and production downtime. Finally, and this is one point I'm going to hit hard on, is a lack of granularity. All these traditional methods do not segment enough. They don't reduce the risk enough. They don't lead to compliance. They're only based on IP address and port. So the problem with the policies that are only layer 4, IP address and port, are several things. For one, there are no process level policies. So for example, let's say here I have a bunch of proxy servers talking to web servers, and I have a Nginx proxy that talks to a Tomcat service. I want to be able to allow over 443, the Nginx process, to talk to Tomcat, but nothing else. So there's this evil process over here. I don't want to take advantage of that 443. And what you find out is with VLANs, ACLs, and security groups, you can't do that. The thing is you say, or you're stuck with IP address and port only, so that evil process gets through. So it basically becomes a pipe into that web server, and the evil process can take advantage of it. So that's one problem with traditional segmentation. Number two is there's no identity-based rules. For example, here we talked about the fact that enterprises are looking to contractors to help with resource allocation. They bring them into the environment and also in cost. And the challenge here, for example, let's say this woman, Allison, who's in charge of the accounting application, and you have Diane in charge of diagnostic application, and they happen to be in the same data center on the same VLANs, but you have one jump box, and you want these two to only be allowed to get to their specific thing that they're supposed to be controlling. The challenge with traditional segmentation being layer 4, it's impossible. So there's no identity-based rules. You can't actually say, Alice and Diane can only access what they need to access. You can't do it because they're only IP address and port based. The other example here, and this is kind of critical too, is no ability in traditional segmentation to use fully qualified domain name rules. And this is very common in the DevOps world today, where you have people setting up things in DevOps for production, and you're saying, okay, for the web servers, I'm letting you get the GitHub and Ubuntu for updates, but nowhere else. DevOps, the other servers, you're allowed to go to Ubuntu to get your updates. And the challenge here again is because it's based on IP address and port only, you can't do that with traditional segmentation techniques. And firewalls are another example. So if people try traditional segmentation like VLANs, ACLs, and security groups, they also try firewalls. And firewall vendors, for the most part, have been pretty honest. There's been one in particular that's not so honest, I won't say who it is. But the key is in trying this, the problem is a firewall is a perimeter device, right? They can even be in the cloud, but they're on the edge of the cloud. They could be between different types of VLANs and things like that on premises too, but it doesn't follow the workload. For security to be successful, it has to follow the workload, and therefore it's cost prohibitive because basically you can't put firewalls everywhere, nor are you going to bottleneck traffic through firewalls to take advantage of these new environments. So the key is that the firewalls are not in the correct place. And then the final group of failures that we've learned from is from first generation software-defined segmentation. There are many. So the first things first is there were 3 vendors who focused on hypervisors and thought the hypervisor would be the method of enforcement and control. Actually, 2 of the 3 vendors who started in this space, including the largest hypervisor vendor in the world, have moved away from hypervisors. There's only one who still does hypervisors. And the problem here was you had the same layer 4 policies. So those examples I showed you, trying to do policy by identity, by process, and by fully qualified domain name, you can't do that. So you have the same problems as traditional segmentation methods. They don't secure enough. And then on top of that, they're not platform agnostic enough. So basically, whenever you have a hypervisor vendor, you have to be able to talk to their hypervisor firewall. So you have to have proximity to it. So it still becomes a bottleneck and a chokehold. And again, only 2 of the 3 vendors who started in this space are still doing it. And then the next thing, and this is kind of critical, software-defined segmentation means an agent. I know a lot of people don't like that word, but you need an agent. It needs to be lightweight. And this is the most important thing. Enforcement must be done by other than the native OS firewall. Now, I know that sounds counterproductive and counterintuitive, but it's true, and I'm going to tell you why. So most vendors out there today, the challenges that they have, and this is the number one issue we find when we go in to do POCs with people who are looking at our competitors, is in Linux, if they use the native firewall which is in Linux, it means you're stuck with IP tables. This means that you are only doing layer 4, so IP address and port. So just again, no process, no identity, no fully qualified domain name capabilities, and so you have a lot of issues. With that said, vendors who use agents who are using native Windows firewalls, you get a little more granularity, but you're missing some important things, and that includes the ability to do blacklists and deny lists. I'm going to show you this later on. But just keep in mind, any vendor out there that doesn't have their own firewall, that's using the native OS firewall, is stuck here at layer 4 for Linux. And Windows, you have no blacklists. It also means that you have contention. It means that you're fighting local admins for policies in the box. It means you may make a change with your agent, but a local admin can overrule you and make a change back again. So that's a challenge. And it also means more latency when you use a native operating system firewall versus your own. Finally, the biggest challenge next to probably the one above is vendors who offer limited visibility through a secondary or tertiary package. So the challenge is most people out there who do software-defined segmentation, instead of having their own visibility, use a secondary tool to do it, or even a third-party package. And what I find is a problem here is integrated visibility is essential to create appropriate labels that lead to policies. You remember the workflow of the 5 steps. You need to create labels, looking at visualized maps, and then create policies out of it. So without having that visibility, you really can't accelerate segmentation projects. And without visibility, it also means we can't, be confirmed that you won't make mistakes. So software segmentation done right. So we've talked about use cases, we talked about the why, the steps, the traps to avoid. Now here's how it works. So using our solution as an example, what we found is most important is when you do software-defined segmentation, it's do it once, do it right. So having the widest platform support available is essential. So if you're sitting there as a CIO, a CISO, an infrastructure director, a DevOps person, you're saying, I want to be able to cover my bare metal, my hypervisors, my clouds, and all my containers with one solution done right, done once, done right. And also, more than just covering these operating systems, you need to be able to grab the orchestration metadata. So, and this must be integrated. So in other words, it shouldn't be a manual process to get to that. So for example, if I have an object that's in VMware, I should be able to pull up things like what is its asset name, its tenant name. So what host it's on, what folder, all the information I need about it. For example, here's an AWS example. Of an AWS object, I need to know the instance name, the image name, the private DNS, the security groups, and we even have things that we don't show here, like it's AWS East, Europe, 1, that kind of thing. So all this metadata allows you, this rich metadata allows you to understand what the workloads are and to provide and create the right labels. And finally here, I'm showing you a Kubernetes OpenShift example. Again, you can see that you want to be able to say, hey, I know, for example, we have this great new EDR application, and I know it's located in this namespace. The node names are this, or the IP address range is this. You want to be able to go through and pull that information into creating software-defined segmentation. The other thing that's really important is having the broadest operating system support. As I mentioned kind of in my introduction, enterprises run a very wide array of operating systems that are manageable. I look at several hospitals and healthcare organizations we work with. They have medical devices that are running Windows Embedded 7. We talk to insurance enterprises, and they have an operation or an application that is dependent on Windows 2008, not even R2, right, or 2003. And the goal is they need to be able to get visibility into these systems in order to protect them because they're no longer having patches and things created for them, as well as things like HP UX, Oracle Solaris, IBM AIX. These things are around forever. They have legs. In fact, these Unix machines were around when I used to have long hair. I mean, these have been around for a long time. And so the key is you must be able to support the broadest amount of operating systems imaginable, from end-of-life systems all the way through the most modern. By most modern, what's also important is you need to have ability in your solution that when new kernels come out for Linux or new Windows release comes out, that within 48 hours, you automatically have an agent for that new operating system or kernel. And so not only do you need to be concerned about legacy end of life, but when you choose a software-defined segmentation solution, also ask how they handle new releases, because that's critical. Because having that broadest OS support means you're covering the broadest number of enterprises out there imaginable. And as I mentioned before, it's important to have an agent, and an agent with its own firewall, not native to the operating system. And the reason for this is, especially in Linux, you want policy granularity. You want to be able to say, I want to have a policy based on process itself, not just by port or IP address, but anywhere you want to get the Tomcat, only Nginx can get to it, no matter what port it is. By user, instead of having a jump box per contractor, which for some of us could be hundreds, if not thousands, well, I want to have one series of jump boxes and be able to say, Allison can get to accounting, Diane can get to diagnostics, and never the twain shall meet, even if it's the same VLAN. And then also fully qualified domain names, the DevOps example I gave is being able to say, hey, listen, when you're in DevOps, the web servers can go to these sites, the other servers can go to these sites, but you're not getting to the internet directly or other things. And then finally, policy blacklists. And this is also critical because the key is if you don't have your own firewall, you can't do this. A lot of times when I go to prospects who are becoming customers, they say the first thing we want to do is stop plain text protocols, or I have a global list of things I want to implement first. And so being able to say rules like no matter what port or IP address coming into production, any system labeled production, no FTPD, no telnet-D, no TFTPD. Sounds easy, but without using a system that can understand processes and blacklists, this actually becomes a long, long list of ports, and there you're not even protected very well. The other thing too about having your own firewall is less latency. And this is what I talked about that seemed a little bit paradoxical before, but we've had, I think at this point, 3, 4, or 5 cases of independent studies of our agent. And this is often common, right? And we have much less latency than IP tables and Windows firewall and Unix firewall. So the concept is we're able to have much less latency than the native operating system. In fact, we have a bank, one of the top 3 banks in the world. We actually have 2 of the 3 top banks in the world, by the way. And they have us on a high volume trading servers. And we only put in about 7 milliseconds of delay in that situation. So they trust us to be there. So other key elements, visibility. So we talked about the need for visibility, and I say one step further, it should be historical as well as real time. And the reason for this is when you're doing maps and policies and things like that, you want to be able to go back in time and say, hey, listen, we might have some things that only update once a month, like getting distro updates. I want to make sure that's included. So give me a month on this application, and let's look at the flows. Also for DevOps and infrastructure people, and security people, it could be a source of forensic information. It could also be a source of compliance information, saying, hey, listen, here's 90 days of information. You can see for a fact that our PCI compliant boxes are only doing what they're supposed to do and nothing else can talk to them. This visibility also gives you the ability to create apply labels easily, find your application dependencies. And the biggest thing about having this kind of visibility, the flexibility to allow you to sort in various ways. So in some ways, it's not just a single pane of glass. It's multiple glasses and lenses that different people can sort in different ways. So for example, one pair of glasses may be someone who's interested in doing rule sets between different platforms. So here you see OpenShift, VMware, AWS, or bare metal. And I may want to come in here and make a change where I could say, here's how people react to the AWS components of our environment. Or I could do it by environment itself, meaning I have production, development, users, and infrastructure. And I want to make sure that when things move from development to production, that only certain things talk to it, that its behavior acts in a certain way. So I may want to sort this map out in a different way than the prior person. Or I may be a compliance person, and I'm interested in isolating, for example, PCI devices. It could be any other compliance standard that you could think of, and how it interacts with the world, to create policies that way. So the goal here is that single pane of glass with multiple lenses, because each person may have a different way they want to view it. And also, you want to be able to show application dependencies, regardless of where they occur. And I've actually purposely chosen a more complex one, probably not one people would start with, but why I chose it is this. In the middle here, you have this whole thing is a billing application. In the middle, you have a Kubernetes workload. In this case here, it is a green unicorn web service, and it talks to a backend database in VMware and into a front-end database in Postgres, and here's how people interact with it. So you're able to see all the workflows of the application. You're able to see everything about it, as well as the labels, the flexible labels. And this is how you get those flexible views, is by those labels. The next thing is you need to have a flexible labeling schema. The idea is we want to remove moves, adds, deletes, and changes. So to do that, we want to take advantage of DevOps and through the user interface to create groups so that, for example, we might have an accounting application. And as we spin up new workloads, we want them to automatically be attributed to the right policy set. We don't want to have it where every time you roll out a new thing that you have to add new policies. So the idea is we allow for dynamic labels within the interface, as well as with DevOps, with scripting, you could push out agents and say, hey, guess what? You're part of the Ansible application. So we take advantage of Chef, Puppet, Ansible in order to be able to do this. You also need the ability to have a policy wizard. So example, we could take these beautiful maps and be able to show the dependencies within the maps really easily, click a button and get down to the process level right away. So the key is this reduces the attack surface the greatest when you can get down to the actual process itself. And you could do this also by identity, by fully qualified domain name. But the key here is this policy wizard makes it easy to go from, I can visualize the environment, I can label it, now I can add policies to it, what is allowed, what is not allowed. And finally, we have, you want to have a fully functional REST API set that is documented. So the beautiful thing here is in many organizations, you have very bright people in DevOps. And as they adopt this, they go, what's really great is I can go in here and actually script a lot of things about how this works. We have Santander Bank is one of our banks. And what they do is they have a great CMDB, and they use our software Centra and their CMDB to keep objects current in both locations. And they use a REST API set to do this. As you can see, here's the dictionary of all the stuff you could do, all the functions, and we give you real world examples of what you can, how you could script it. So it makes it very easy. This should be a part of every solution that you choose to do software defined segmentation. And now we're up to a Q&A section. So Mitch, do we have any questions?
Oh my gosh, we have a lot of questions.
Awesome.
Awesome. Great presentation.
Thank you.
So I mean, I was riveted. This is awesome stuff that I love. So I think one of the things is just setting kind of context here. There's a question from our audience about how is software segmentation different than some traditional things like we know 8021X, VPNs between servers, machine-to-machine communication, end users, and network access control. Those are all traditional tools that IT is used. How would you differentiate the software?
That's a great question. That's a great question. And I spent 7 years at Cisco working on Cisco NAC and Cisco ICE, so I'm very familiar with those technologies. So let's start with .1x. .1x is a great solution. The challenge with .1x is it works in certain very controlled environments well, ones that are very static and don't change very much. The idea is .1x is most found on premises because of the need for the hardware, and it's just not Cisco hardware anymore. All hardware now has .1x options. But I really see that being more of a static approach than really being something that would be all-encompassing across the board. There are some assets that come with good NAC solutions, including .1x solutions, that could be helpful for us. For example, a lot of times they have auto-discovery techniques. So we've been asked, in some ways, in apples to oranges, in certain situations where they use NAC, to also use us to then put an agent on the new .1x thing that has arrived, or a label saying, we have a new camera, right? So in some ways with .1x, it's kind of apples to oranges, but there are some synergies that we can get out of it. VPN connections are great, but you can also secure negative traffic as well. So it doesn't mean you have visibility. It doesn't mean you really have true compliance. It's a great thing to encrypt everything, but the point is that you're really not controlling the workflow. You're encrypting it. You're hiding it. So that's how I would respond to that. Great question, by the way.
Yeah, it's interesting. I remember you, just so I can interject here, Dave. I remember at one point people were thinking that every communication was going to be a VPN, machine-to-machine VPN communication, and that was our environment. But clearly, that's not where we evolved to, especially as applications got more complex.
Yeah, absolutely.
Are you? A question I might just interject here to add on to this. It sounds like you're not necessarily saying it's always a replacement. Software-defined segmentation to these other existing technologies. They have their role, but software-defined is much more dynamic. Is that fair to say?
It's very fair to say, and I'll give you a great example, a real-world example. We had one bank, another bank, not Santander, and basically their challenge was they realized, to their horror, they had 700 VLANs between production and development that were shared. So same IP space.
Old wiring closet.
Yeah, yeah. So that was VLANs and IP addresses, and they had a situation where a DevOps person typed a few commands and sent billions of dollars to another account. And they said, well, it's going to take us 4 years to re-IP address and to re-VLAN everything, and that's going to hurt our business. It'll hurt our competitive advantage. So by using software-defined segmentation, they were able to use DevOps rollout agents, and in a matter of weeks, they were able to segment using software-defined segmentation without making any VLAN changes or IP address changes. That's really when I think of NAC and traditional techniques, and I think of what is the advantage of software-defined segmentation. That is it, right? That's a great example. Another company, also a bank, was having problems with physical security in their banks, and globally rolled out 10,000 cameras. And to their chagrin, they found out that these cameras were really shunts to their heart. Everyone was on a data center VLAN. So they then went through an audit and said, that's not good. And so by rolling out software-defined segmentation, again, in a matter of a week or so versus years, they were able to shore up their new physical security with cybersecurity as well. So again, it's really a matter of that and granularity and automation and speed.
Okay, excellent, excellent. Next question is, do you consider GuardiaCore similar to an application firewall, or is it significantly different than that?
That's a great question. So it is more than just an application firewall. So the idea is, because what we're trying to do is look at not just the individual host, looking at the workflow. So we allow you to do things like make policies, like I talked about earlier, that say in the production environment, no matter what it is, no FTPD. So you can't talk to FTPD, you can't talk to TFTPD in this environment. So it's more on, so you have the global rules, and then when you get down to the workloads itself, because you are working on labels, the goal is you're really looking at, this is how this group of objects reacts in this environment, and it's dynamic. As more objects are spun up or spun down, it occurs dynamically. So that's how it's different than an application firewall or a host-based firewall. And again, it also deals with identity, fully qualified domain names, and processes. Great question.
Okay, fantastic. Speaking of identity, around user access control, because you were describing, if I can interject, some of the policies around, or Susie can access this, Tim can access that, etc. Yeah. Is that coordinated through a directory or a third-party policy manager, or is it all self-contained within GuardiaCore itself? How does that work in a bigger system of IT management of user access policies?
So usually that is tied into an enterprise's Active Directory systems or other identity stores. So the key is that when we attribute identity, just as when we talk about being able to grab orchestration data from all the platforms that we work on, so knowing that something is an AWS East Europe 1 and is this workload, we also want to tie into the details of your identity stores. So the idea is both for creating policies and also for role-based access control. So the idea is we can absolutely take advantage of existing identity stores to do that. We don't want to be a bottleneck for your identity.
Mm-hmm. Okay, good. Let's see, this participant, let me kind of try to consolidate this question down a bit. So what about logging, diagnostic, forensics, compliance, protection from viruses, malware? There's a lot of things that this kind of exposes in terms of both doing diagnostics and then finding out when there's an incident may have happened. How do you support that part of the business?
So there's two ways. Let's first start with the logging, then I'll get into the breach detection incident response. On the logging side of the house, because we have real-time and historical visibility, that is everything that occurs in the environment, often we are used not only for enforcing security and compliance, but also ongoing validation. So people can use those logs going forward to say, show me all block connections going into this application in a troubleshooting fashion, or show my PCI environment and that the only interactions we have are between the point of sale system and its backend database order entry system, nothing else. And you could do that because you have the log files. So those are essential for a good software-defined segmentation solution. Is if you're sitting there enforcing things, you need to be able to show all workloads out there, not just the ones that you're on, and be able to show all the logs and everything about it. So that's the first answer to the question. The second is on breach detection incident response. Our company, Guardicore, actually has a lot of good breach detection incident response features, which I haven't covered in this presentation. You can go to the website and see it. We cover, we have a lateral east-west traffic sandbox. So for failed traffic, we dynamically take that traffic into a sandbox and analyze it and give you alerts and warnings based on that. We have all sorts of other rules within the software to do breach detection and incident response, looking for lateral movement. And we also have a reputation store, and it's a unique reputation store because we are the experts on lateral movement in data centers and clouds. We even have one of the cloud providers as a customer. We have a reputation store that's very different than, let's say, VirusTotal. So people will look at us and say, 87% of the time, you see things that VirusTotal will never sees. And we go, yep. And basically, so part of what we do is we look at every process, domain, and IP address, and look for for reputation scores as well. So the key is we're very much into breach detection incident response, and that's the ways we do it through the software. But also we have a group called Guardicore Labs, and this crew came from the IDF 8200 and Unit 81, and bright people who look at a global sensor base of sensors and forensically look for problems. And they have come up with many catches. The current one, Summeru, I can't say that very well, they discovered 2 years ago. So the largest, basically, cryptojacker in the world that is traveling faster and spreading faster than anyone else, we discovered 2 years ago. We discover holes in vSphere that allowed you to get root access to all your guest operating systems that we exposed at a Black Hat, among other things. So the crew is very much on that. And finally, we have a thing called Infection Monkey. Infection Monkey's free. It's open source. It's on GitHub. And it allows you to simulate attacks safely, by the way, and for free in environments. And it's beautiful. It not only shows you the attacks, it shows you a very prescriptive outcome. And here's what you need to fix, kind of thing. It includes tools that you want to be protected against. So, for example, everyone's familiar with Eternal Blue, which was a SMB exploit. We allow you to actually run that in environments to see if you're vulnerable for it. Struts 2, which is how Equifax was taken down through the web services. We run that as well. But the key is you get a prescriptive outline of what you need to do to fix everything. And then most recently, as Zero Trust has become a well-adopted platform, we also have Zero Trust reports, which assesses what it's done in a Zero Trust fashion and gives you prescriptive results. So the key is we are very much into the breach detection incident response, both in our software-defined segmentation solution and also in our other activities.
Well, just to interject a little levity here, Infection Monkey, that sounds like a great Dustin Hoffman movie.
It does. What's really funny is I kind of didn't like the name at first. I've been around for 21 years in the industry. And whenever I showed up somewhere where my company had developed a tool, and the tool was called Blaster, Scissors, some violent name, people generally would not want to run it. But if it had a really innocuous name, it would be better. So I didn't necessarily like the Infection Monkey name. However, I got to tell you, it is really well loved, tens of thousands of downloads. In fact, we've even had people come to us saying, "Hey, I downloaded Infection Monkey. Now let's talk about your solution, Centra, because this proves that I need to have Centra."
I'll bet. I mean, I'm sure it exposes a lot of interesting things, that's fantastic. Let's get into, I'm going to try to consolidate a couple of questions. There's a lot of questions around the workflow. And one is, how is that constructed? Is it a dynamic discovery through your code? Is it a declarative process? How do you create those kind of in and flow diagrams? And then if I can kind of also seed you with the other part is, are you also talking about securing those workflows specifically, but not as all layers, specific layers? How do you do that?
So the key is this. Let me go back to, I think I want to see, going back a few slides. So let's first talk about that mapping. How do you map out and create labels first? Because that is probably the first major part of that question. And there's also a question on collection. So actually, let me start with collection first. So collection is done not only through the agent. So when the agent's on a workload, you get very granular things about what processes are there. But the key is, even before we put an agent on the device, we have all the orchestration data. So when we went back, let me go back a few slides here. When we go back a few slides and we look at the orchestration details, all right, go back over here a second, like this here. With all the orchestration details, this comes into Centra. And so it allows you to create labels based on things like, if it has a default AWS security group, it goes in this bucket. Or if the name begins with blah, 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 put it in this bucket, right? So the idea is all that orchestration data, even before you put in agents, is critical to help understanding workflows and things like that. On top of that, what we do is we then use the agent data that we get. Let me go forward again. Use the agent data to create labels as well. And also you can use your CMDB and other types of data stores to import information as well. So you see in the corner here, you have a number of labels that we created. So for example, this is parts of this are part of compliance PCI. Some of it's not PCI. It's in the United States. It's OpenShift namespace, the space called billing, applications billing, right? So you have all these different labels, some that come from the orchestration, some that we come up with that allows us to label these devices and label them as part of different parts of the organization. And the beauty of being able to do this means your rules and your policies then can become dynamic. It then can become a situation where, let's say billing started in development, and development had a series of policies that production didn't have. You could put that in. Billing is an application and has different components. So you're able to write policies that are related to this application itself. So the beauty is it creates a hierarchical approach to make it easy to have policies that are fluid, dynamic, and based on the workflow. Does that answer the question?
Yeah, I think it hits at a lot of it. There's another question. Okay, so that's kind of how that's created. How about down to the kind of Kubernetes container layer? There's a lot of work right now around products and technologies emerging around application, inside the application security because of microservices and the
Correct.
proliferation of containers and services. How does that fit into your picture?
Well, going back a few slides here to the one that showed, so we know that the containers and microservices are becoming king. I think that we're kind of early, but because we know they're becoming king, and we know that they're going to expand faster than any other type of new innovation, we have embraced it. So, for example, here, this application here, you see a Kubernetes OpenShift process down here. You see it here as well, and up top VMware. So the idea of being able to integrate these new microservices into the actual flow of your applications is critical. And so we do that because we know how important it is. And I think that you're going to see it in the next few releases. We'll even be looking at things like Lambda workloads, because those are becoming popular. What Lambda workloads are in plain English is someone else's containers, just as cloud is someone else's data center. Lambda workloads is someone else's containers. And so we've taken a lot of effort to make sure we have the ability to do that as well.
Mm-hmm. Okay, good. Speaking of Kubernetes and containers, Jeremy asked a question about, can this be deployed as a sidecar in Kubernetes?
It kind of is a sidecar, but currently it is at the container host level. But that's a very good question. So currently what we do is we're at the container host level, but absolutely could be a sidecar, and it could be pushed out as you push out your workloads, your container hosts.
Okay, very good. There's another question Jeremy had actually is can this, you mentioned earlier kind of a policy agent, can it be managed through tools like Open Policy Agent?
So yeah, because the key is that any kind of scripting or playbook that you have, you could push it out that way. So the key is we've had people use any number of playbook technology and software to push us out. Even Titanium, for example. So you could push this out in any way you would like to push out. We even had people embed our agent into their own agent. So some of the MSSPs we work with, where they embed our agent into their agent and push it out that way as well.
Okay, great. Our final kind of group of questions I would describe this way. There's a lot of interest in you mentioned the REST API, and of course, infrastructure as code, Terraform, cloud,
yes,
PaaS and IaaS interfaces are of great interest to a lot of folks. Talk about how this would fit into an infrastructure as code kind of model.
So the key is the full solution. When we code the interface, you have to make the REST API call first. That was a DevOps axiom that we took. Then the next stage was not only do you have to code using the REST API first, you have to document it, as you see here on the screen. So the beauty is for us, it's a boom because our entire solution is a REST API call, and people take advantage of that. So the example I gave was Santander Bank saying we have a CMDB, and unlike sometimes CMDB could be junk in, junk out. Theirs was not junk, and they came up with a way to dynamically using the REST API to keep it in sync. So that's a good example. People have used a REST API call to call out various first tier SOC solutions, right? Help desk solutions, trouble ticketing. ServiceNow is a great example of that. And then most importantly, and more tied to the original question, is because we can push this out with playbooks as part of provisioning scripts with the REST API, you can sit there and say, I have 1,000 new workloads. Oh yeah, they're production, they're non-PCI, and this section are web servers, these are proxy servers, and these are backend databases. Go. And then immediately you provision this. So there's no manual moves, adds, changes, deletes, which again, part of this is keeping things accelerated, taking advantage of that DevOps cloud-based architecture world, which again affects everyone, not just people who have clouds, but everywhere.
If I can, thank you. If I can interject my own question on this, it seems
Please.
like this would be very applicable to a multi-cloud environment where you want to kind of manage the security across some of the differences between clouds. Is that a correct assumption?
Absolutely. Absolutely. By far, absolutely. And the reason for that is when cloud providers came into being, they all chose their own security group methods and they're per VPC. So again, if you have AWS and Azure, they're different. And they're different VPCs are different VPCs. The same is true with Google Cloud and OpenStack, CloudStack, IBM and Oracle clouds. So the key is my point all along is a lot of people start out by saying we're going to be an AWS shop, we're going to be an Azure shop, we're going to put our investment in Azure. And what I'm thinking in the back of my head, because Mitch, I don't know how old you are, but I know how old I am. I remember seeing Unix and Windows operators argue over who gets the next application. But today, no one ever argues about that. You have to know it all.
They put it this way, I'm old enough to have learned that nothing ever goes away.
Right. Yeah, nothing ever goes away. Correct. Nothing ever goes away, number one. And number two is you're going to use it all. So for me, whether it be through a merger acquisition, a partnership, or what have you, you will be using multiple clouds in the future. And so the key is having a solution that can work across all the clouds in a uniform fashion. And then more importantly, back to my earlier stuff on granularity, can actually do, besides layer 4, can actually do process level enforcement, identity level enforcement, and fully qualified domain name enforcement is going to simplify your life so much and secure it.
Excellent. Excellent. Well, I keep thinking we've exhausted questions and more roll in here. We have another question about the testing aspect of this. Is there a way to test deployment of the changes in a feature toggled way?
Absolutely. And so, yeah, the way that we do that is number one is usually we push out in alert mode only. And then once you figure out that you have something that you like, you then put it to block. So the idea is people usually, when they start with this, say, okay, let's push this out. Let's see what we got. Okay, that's great. We'll push it out. And actually, let me pull up a slide here. Let me see if I want to show you here. You go. So for example, here you see the slide above us on billing. So you go in, you add your allow rules, you have your deny rules somewhere else, and then basically you start in alert mode in the center column here, in alert mode, and then you look at the alerts that come through and say, oh, wait a minute. We forgot to add the fact that it goes and does an Ubuntu update once a month. Let's add that as well. And then eventually, when you're sure about the application, you go from alert to block. So there absolutely is a way to test. Also, because this is so important for our customers, not only in this screen can you do that, but also as people are looking at incidences of alerts, can say, I want to look at this a little closer and can zoom in on what it is. So not only do we do it from a policy creation and management perspective, but also on the alerting side of the house. When you see an alert, you see what policy triggered it. You can see whether it was alert or block. So the idea is we've added several places in the interface to be able to evaluate policies and if they're working or not, and whether you want to go to block or not. Great question.
Okay, fantastic. We can thank Jeremy again for that one. Yeah, he was a
Thanks,
repeat
Jeremy.
question guy. Well, I think we've covered the questions. I'm just curious. I'm really interested. I hope we have a chance to maybe see a demonstration of your technology in a future webinar. Is that planned?
Let's do it. Let's make a date. Mitch, sounds perfect.
Okay. Okay, I would love to see it. I know that. I'm really intrigued and learned a lot. Well, thank you. Thank you, Dave. I want to thank Dave Klein, who's Senior Director of Engineering and Architecture at Guardicore for today's presentation, and Guardicore for sponsoring the webinar. Just a reminder that we will send out a email with a link to the recording and to the slides. You can also get those on securityboulevard.com. And absolutely be sure to check out Security Boulevard for any future webinars coming up, including with Dave and with Guardicore. It's been my pleasure to be your host and moderator and to have Dave on the webinar today. I appreciate everyone's participation because I know your time is extremely valuable and appreciate you spending the hour with us today. So wish you have a great day and be careful out there. Thank you, everyone.
Thank you, Mitch. Thank you, everyone.